Fox, socks, box, knocks and box, fox and socks, knocks on fox and socks and box, socks on knocks in an oblique box. Isometric clocks takes ticks and talks, sir. Don't you know this, Mr. Knox, sir? We're going to learn about oblique and isometric sketches today, folks. It's time. It is time to do this. Here's the issue, okay? Here's what's hard about art. I'm not a particularly stupendous artwork master designer. However, art is hard, at least 2D art can be very, very difficult. All art is challenging in some form or another. But trying to make things look good and look realistic on paper can be very challenging. So today I'm going to go over two common methods for drawing items that you might find in like a manual or in many other forms of art. And the reason art is difficult is you're taking something that is three-dimensional, that has a length, has a width, and has a height. You're taking these things and you're putting them onto a surface that only has two dimensions. So you're essentially losing a dimension. So the two things that I'm going to teach you today are sketching techniques that try to preserve all three dimensions as best they can. Okay? Here's the perfect example, right? If I say like, I got to go up here, sorry. Come on, team. There we go. All right. Let's see. What am I drawing right here? What do we got? Okay, could be an airplane. Could be we're looking from above and we don't see that third dimension. Could be we got an airplane going on here. Who knows? Could be, it's a great drawing, Mr. Slagle. Could be we got a dude with a cool hat riding a bicycle. Maybe you guys have seen this before. I'm really great at art. Look at that. Super. Yeah, look at that. The guy riding a bike got a big old hat on. Look at that. Who knows? Okay, when we take something three-dimensional and put it on paper, we lose a little bit of information. Just a little bit, okay? So it turns out that has a name. There's a name for something when you take something three-dimensional and put it onto a two-dimensional surface. That is called a graphical projection. A graphical projection. This is the very famous Mercator projection of the Earth. The Earth, of course, is round. There's a host of people on the internet that think otherwise. I'm here to tell you it's the truth. Spoiler alert. The Earth is round, and to take the surface, imagine trying to go ahead and do this. If you have any little oranges in your fridge, try and peel an orange and turn it into a perfect square. Okay, try and peel it so it's really easy to navigate your way around the orange, and you can lay a grid out on the orange. It's very, very difficult. Okay, the Mercator projection has some serious issues. For example, Exhibit A. Let's go ahead and take a look at Antarctica down here. Looks like it's basically the same amount of land as the rest of the Earth, which is a problem. Okay, this Mercator projection distorts the poles of the globe. It's way, 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 way off, big time. Greenland's much too large. Alaska is too large. It's distorted. It's stretched. When you take something three-dimensional and you put it in a two-dimensional, you lose a little bit of information. Okay. There are other projections of the Earth. So that's a graphical projection, 3D object projected onto a 2D planar surface. We're trying to write it on there somehow. There are many ways that people have tried to map out the Earth in a fair manner. But like even people that make globes, you're cutting tiny little strips that are kind of pasted on there. Or at least that's how they were made back in the day. This is a different projection of the Earth. This seems a more accurate, less distorted way, but it's still not, you know, it's not great for navigating, or like, what is it like when you're traveling from here to here, so on and so forth. Anyways, I'm kind of getting, I'm just going way too into this definition of what a projection is, but that's what we're doing. And it turns out you kind of end up, the two ones that I'm going to teach you today are not completely realistic, but one of them is much more realistic than the other. So let's take a look at that. Whoops, I'm going to pull the slider up here. Don't cheat. Don't you pause it. Don't pause it. Okay, the two techniques are oblique and isometric. Surprise, surprise. First, let's look at oblique and the key features of that. Okay, so oblique drawings have this definite front face. They typically have like a rectangular based front face. By rectangular, I mean you have these right angles. You've got these right angles, and then you've got your receding angle. That angle is the angle from horizontal, that these are kind of tilted up. And you can do, this is looks like a fairly low angle, meaning we're kind of down low to the ground looking at it. You know, you could draw something like this much higher with an oblique sketch. But so you have this front phase, you have horizontal, vertical, and receding angle lines. It's not quite realistic. It's kind of distorting the shape of the box, if this is a box. But all right, sorry, we're back. Technical difficulties. Steve is really, he's my mic guy. He's had some issues there. It's okay. Just have to take it out of his paycheck. We'll get my eraser. There we go. All right, cool. So here we've got that right angle. Yet again, you can see these kind of blocky. This is this face here is our front face, and then here is our receding angle heading back. And this one maybe looks like a little bit higher of an angle. The line is a little steeper. That's how I would be telling that. A little steeper of a line. Okay, so different ways to draw these shapes. You got this front face. You've got these horizontal lines like that coming across. We have these. Dead giveaway. The issue is this is not realistic, and I want you to think about why this isn't realistic for a second, and then I'm going to kind of explain the best I can. Okay, here's why. Here I got a little, look at this. Got a little electrical socket, tamper resistant, got to be up to code. Let's say I wanted to draw this box. I'm going to look at the camera. If you're looking at the front of the box so that it is perfectly rectangular, it makes a rectangle, it's actually impossible to see the other sides of the box. There's no way for you to do that. You won't see the top, the side. That's not going to happen. So oblique sketch is unrealistic because it's kind of warped. It's warped the perspective. This is slightly warped. You can't tell because it's a thin object, but it is slightly warped, and that's an issue. Now, when we compare that to isometric, which is this one right here, you know, this is still not perfectly realistic, but it is much more realistic. There is a way to do this, and that's if you're looking at kind of down at the top corner of the. This is not perfectly real, but it's pretty close. You can get all three sides if your center point is kind of this top corner or this edge. Okay, so let's see this same shape drawn isometrically. Typically in isometric, you know, it naturally looks a little nicer. Once you see it, you'll notice that the paper in the back, the graph paper, this paper is kind of drawn horizontally. The lines back here, you can see these lines kind of jetting off in different directions. So that's isometric graph paper. Okay, key features, no horizontal lines, no 90-degree angles, and this is not a hard and fast rule. That's most of the time. That says most of the time. Okay, there are some exceptions to that, but not many 90-degree angles. You don't see, like here we have this 90-degree angle, 90-degree angle. We have these horizontal lines. You don't necessarily get that over here in these drawings. Lines are not always drawn 30 degrees from horizontal, but on typical isometric graph paper, you have the receding angle here and the receding angle here. When I am drawing obliquely, one of the key features for me as an oblique, when drawing obliquely, is there's only a receding angle really in one direction. So if you look at the bottom edge of the object, you have these are your receding angles headed off in different directions here. And they're all parallel, right? If they were to continue on, they're all parallel to each other, right? And then the top and bottom are parallel and the sides are parallel. So that's a key feature of an oblique drawing. Compared to isometric, you actually have two receding angles. You have one coming off to the right, so all of these go together, and you have some coming off to the left, and all those kind of go together. I really should do those in a different color. Let's do that. Coming off to the, oh, there's another blue one there I missed. You have all these lines coming off to the left, so you kind of think of these as there are a couple lines that are not perfect. Let's go to blue. This one is one of the blue receding to the right. Receding to the right. Those are all the left ones I think I got. These two are kind of a different angle that I'm not going to worry about. And then in green, we'll have kind of our vertical coming across like this. Vertical sides. Okay, so you kind of think about all these edges, and all these red ones are parallel, all the blue ones should be parallel, all the green ones should be parallel. Similarly, the receding angle lines here should be parallel, and I kind of went over that. Okay, I call this is a pseudo-realistic viewpoint. It's not perfectly realistic. We will learn a more perfect viewpoint for drawing an object, and I really want your first object today to kind of be focused on something rectangular. So let's practice drawing these boxes. With an oblique drawing, step one is you typically draw that front face. So I'll draw the front face, and remember it's really just drawing a square. The next step for making this perfectly accurate is I'll come and draw my receding angle. So I'm going to take this line like this, and I'm actually going to cheat a little bit. You can take that line and we can copy and paste it. Bring it down here. Okay, it's the same line. It should be the same length, exactly the same length, and exactly at the same angle. So the next thing I do, so I draw my front face. Next thing I do is I draw my receding angle when drawing that box, and then I can come through and connect those back lines together. And we've got our little cube or our little box with a fox, sir. And now what I can do is I'm going to come and select my green, and I'm going to do kind of the order that I do my isometric sketches in. My isometric sketches, if I'm drawing this cube, I don't start with one of the squares. I start with actually the front edge. So I start with an edge. Think about that edge, and then I'm going to grab red, and then I'm going to draw my receding angles like that. And I'm going to freehand these ones. That's okay. You want to draw till it's vertically is right underneath it. I will draw a similar receding angle this direction, and I'm going to extend out parallel till it's right underneath it. Okay, I've drawn my receding angles, and then my last step is to come through and finish this off. So my last step is I'll come through and make these lines parallel like this, draw down, and we've got our cube drawn isometrically. Now, a lot of computer programs and CAD software You won't see this because it's not realistic. CAD software really likes this isometric viewpoint. And CAD is an acronym. It stands for computer-aided design. So computers, like when you're designing on a computer, you basically will be looking at, you can rotate this on your screen, but it is a projection of the object. And you can look from different angles, top, bottom, side, or you can look from this isometric viewpoint. So hopefully that's been helpful. All right, so let's talk about what each of these are, whether they're oblique and isometric, and how we know. Okay, to go ahead and take a guess, and I will do the big reveal. I have a horizontal line right here coming across. That's a dead giveaway in a lot of senses, and we got right angles. Okay, it's probably oblique, but the big clincher here is we've got only one receding angle going off from our front face. All these lines are parallel, and they're all headed out in that direction. Now, if I were to draw stairs, I'm just going to draw a two-stair. If I were to draw this isometrically, I draw the front corner of the first stair, and then come out this way, make sure it's parallel. Draw the top of the stair, draw that same line over here, come across, draw my second stair up, and I'm still just working on that one angle. Come across here, and I'm going to kind of end it right there. So if we were drawing stairs isometrically, you end up having this receding angle to the left, this receding angle to the right. You can see you're looking for more of a top corner view than you were here with this oblique. And this definitely looks unrealistic. If you were looking at stairs directly from the side, you wouldn't be able to see the top. So I'm partial to these drawings because I think they just look a little bit better. So this one is oblique. This one is isometric. Alrighty, folks. And then this one, go ahead and take a guess. What do you think it is? Okay, this is also oblique. And here's why. This is oblique because you have this front face, and you've got this one receding angle headed off here. This box, if you look at something boxy in the drawing, everything's headed off kind of in the same direction. And that is a pretty good giveaway that we've got an oblique sketch. We also have some horizontal lines and right angles, and this looks like a perfect circle. It doesn't look like it's been warped at all. Okay, I love this drawing. Here we have a little house layout. This is done. Take a guess. Yes, if you said isometric, you were correct. Isometric, you have a vertical line is what you're kind of focused on, and then you have the two receding angles headed out. Vertical line, two receding angles. What's crazy is every single object in this drawing follows that pattern. The stairs, you can see them right there. We're looking at the top in this instance. The stove, you have that vertical edge, the two receding angles. The window frame, two receding angles. Now all of these lines on the right are parallel to each other. The toilet even. You can see it in the toilet. All the lines going this direction are going to be parallel. So this is isometric. There are the two receding angles. Also, do you guys see any horizontal lines? I think the closest one is probably like right here on this piece of paper, but that paper is tilted on the wall, right? That's why it's horizontal. Everything, all these lines are following either the vertical or the receding angles. Okay, you should see no horizontal lines in an isometric sketch. Okay, this is the hard one. Take a guess, let me know what you think. Okay, there are two ways to take a guess, or two ways that are common that I get to justify this being isometric. First is, look at this top boxy piece. The top boxy piece, you have your vertical line there, and you have your two obvious receding angles. So that lets you know it's isometric. The other thing is so this edge has been chamfered, which means it's kind of been cut or snipped, or cut down, right? If we were to complete this box, you can see those lines would come to a corner, and that's a dead giveaway that it is isometric. A lot of game designers will draw isometrically as well. This is isometric. Okay, you have the edge of the barracks going off in this direction, going off in this direction. You have the edge of your refinery, you have your receding angle this way and this way, so on and so forth. It's an old game, Command and Conquer Red Alert. Even the dog's legs, if you look at the dog's legs, it's following an isometric pattern. The trucks, man, it's just so cool. Awesome. All right. So yeah, old, like a lot of top-down games run on like an isometric pattern in the game. Whew. All right. Back to school. Back to school. We're going to draw my lunchbox. And we're going to do this isometrically and obliquely. Let's have some fun. So on your assignment, what you're going to do is you are going to pick 2 items in your house to draw. If you have a printer, I have uploaded oblique and isometric graph paper onto Google Classroom that you can download and print to help you draw if you're struggling drawing. If you think you can do it freehand, then by all means do it freehand. The rubric for this, for the drawings, is on the class website, so please make sure you read through that thoroughly. But basically, I'm looking for you to take, if you don't have a printer, take a sheet of like printer paper and fold it into fourths, 4 equal pieces, and so you can have those folds on there, spread it out. You're going to pick 2 items and you're going to draw them each obliquely and isometrically. And they don't have to be perfect, but they shouldn't be really, really tiny. They should take up a good portion of the page. I would like you to label what the item is and also the viewpoint from which you were drawing. Yeah, and I also don't want the items to be the same shape. So try and pick things that are maybe a little bit different for you. So like maybe I would use this drywalling thing. I forget what it's called. The hawk or something, I can't remember. Maybe I would use the drywalling thing and my lunchbox, and then I would call it good. Okay, so draw 2 items, say what it is, say the viewpoint. So I'm gonna do the homework as for an example. I'll give you what I'm looking for. So you would say like, this is a lunchbox, and we're gonna do it first, oblique status. So when you're drawing oblique, you pick your front face. The front face is the one that's like the pattern is continued throughout the object. So I would not use this for the front face of my object. I'd probably use this because that shape continues on throughout the whole lunchbox. Okay, so I'm going to come through. If I'm going to draw my lunchbox here, it's got I'm going to draw the front face first. Okay, so that's going to come down like so. It comes down. It's kind of flat, little rounded corners. Comes across, comes up, like so, and then the lunchbox has this kind of dip down. So I'm gonna, that's the corner. It looks like it kind of comes down like that, and then comes up. Again, not perfect. That's okay. Coming through, has the top of my lunchbox, comes down. There's like a little circle with a button that I press on one side. Great. That's looking like a good drawing for the front of my lunchbox. Now, what you want to do now is it's time to do your receding angle. So what you can do is take this lunchbox and kind of stretch it out like so. Now you want this to be the same exact drawing and shape on the other side. So you're kind of coming down. You might want to draw out and see this edge and where you want it to be first. And it's going to come up like that and swoop up for the handle. And then this edge is going to come down. And let's do that bottom edge now. It's going to come out and curve up to meet it. Okay, so we've drawn our lunchbox. I'm going to go ahead and add in this nice little handle feature into my into my oblique drawing as well. So we kind of have this little handle. All right, and if it's kind of written, it's got like some letters on it. If you want to go all out, Draw some letters on there. Lunch, yum. Okay, make sure that those letters are following that pattern. So this is my lunchbox drawn obliquely, and this would be, if you did this of this quality 4 times, you're going to do just fine on the project. What I'm looking for here with oblique is you have that front face. Okay, that front face is kind of repeated. You have horizontal lines, you've got your vertical lines, and you've got your receding angle. Okay, that's what I'm looking for. All right, let's now do the second drawing, which would be my lunchbox done isometrically. And instead of starting with that front face, I'm going to start with this kind of edge, front edge, which is coming down like that. It kind of let's come down this way. It's kind of got that bent edge, and we have our receding angle headed back that direction, which kind of arcs back up like this. Okay, coming around. You now have the kind of the bottom part of that. That should be parallel to that bottom line. This is like of the lid that slides. And then, you know, one thing that's really key here when you're drawing these is if you want to find the middle, you need to kind of find the middle between these 2 lines. It looks like about there, and the middle between these 2 lines, which is about there. And that's going to be, or right here rather, that's going to be kind of your way that you come up here to find the top of the handle. Now the top of the handle also has to be parallel. So that lunchbox, try that again. That lunchbox kind of arcs, and then comes up to meet the handle. On the way down, it goes down and then arcs down. Now let's work on our second receding angle, which is headed off in this direction. Comes up, we have the kind of the top part of our lunchbox of the lid that comes up there, and then that same shape coming across. Man, this is fun. It's just so fun. Okay, and then coming across this direction, and it's not looking great. I have a little bone to pick with my drawing, and you know, if you need to take some time and do some erasing, that's something that is encouraged here. Do some erasing. You say that doesn't look quite right. Come back and give it a little fix. And now it looks so similar to oblique, but hopefully you guys can see the difference. You know, there's my lunchbox handle coming through, and we can write lunch on here if we want to. Notice even this line here is going to be parallel on the lunch, and then I got to draw my circle. All right, there's my lunchbox drawn isometrically. Let's flash back and forth and see the difference. Front face, and then you got your kind of front edge. Front face and then an edge. Horizontal lines, no horizontal lines. Looks stretched out, doesn't look stretched out. Yeah, okay, I think you guys have got it. If you'd like to watch a professional explain isometric and oblique art, that is on the website. So hope you guys have enjoyed my lesson, and we'll see you next time.